If blood is the body's high-speed highway, ferrying everything from oxygen to hormones, then its newly discovered microbiome is the roadside tavern we didn't know existed, stocked with tiny molecular messengers, microbial debris, and surprise guests who may hold the keys to aging itself. For decades, science assumed that blood was sterile. But with advances in ultrasensitive sequencing, we've learned that blood harbors microbial DNA fragments, low-level live organisms, and most crucially, microbial metabolites, compounds originally brewed in the gut, tweaked by the liver, and delivered system-wide through the bloodstream like tiny chemical diplomats. Now, biotech is eyeing this microbe-human chemical collaboration and asking, what if we bottled it? Enter the next frontier in anti-aging, nutraceuticals based on blood-borne microbial metabolites. Forget generic multivitamins. These future supplements will be precision-engineered from nature's own metabolic library, mimicking or enhancing the molecules that beneficial bacteria naturally secrete into our bloodstreams. Among the rock stars of this new class are the indole family and short-chain fatty acids, SCFAs, molecular overachievers that seem to touch everything from inflammation and metabolism to skin health and cognitive resilience. Let's start with indoles, fragrant little ring-shaped compounds derived from the amino acid tryptophan and fermented by certain gut microbes like Clostridium and Bacteroids. Indoles like indole 3, propionic acid, IPA, indole 3, aldehyde, and indole 3, acetic acid have already shown extraordinary promise. IPA, for instance, is not just a potent antioxidant. It's been dubbed nature's brain shield, protecting neurons against oxidative stress and improving blood-brain barrier integrity. It even seems to modulate serotonin signaling, suggesting potential benefits for mood and sleep, both of which spiral with age. Future supplements may include synthetic IPA analogs or perhaps slow-release prebiotics designed to feed indole-producing microbes directly, like customized fertilizer for your internal pharmacy. Meanwhile, short-chain fatty acids, primarily butyrate, propionate, and acetate, are fermented from dietary fiber in the colon, then absorbed into the blood where they influence immune regulation, energy metabolism, and epigenetic aging. Butyrate, the celebrity of the bunch, is known for enhancing gut barrier function, reducing systemic inflammation, and even activating AMPK and inhibiting DAX, two molecular switches deeply tied to longevity. Engineering a supplement that mimics butyrate's actions without the olfactory trauma of ingesting the real thing is already underway, with tributyrin and butyrate prodrugs leading the charge. Imagine a capsule that not only fuels colonocytes, but also sends rejuvenating signals through your vascular system. It's like a gut-to-blood telegram that reads, "Keep calm and age slower." Now imagine stacking these microbial metabolites into customized anti-aging blends. One version might combine IPA for cognitive support, butyrate for inflammation control, and urolithin a gut-derived metabolite of allagitannins, for mitochondrial rejuvenation. Another might target skin aging, using phenylpropionates to boost collagen pathways while reducing UV-induced DNA damage. The packaging wouldn't say anti-wrinkle or brain booster. It would list exact molecular mechanisms, supports mitophagy, modulates cytokine response, promotes telomerase expression. Its longevity, scientifically literalized. Of course, there are challenges. Blood-borne microbial metabolites are context-dependent. They work best when part of a living ecosystem, and their effects may differ depending on your microbiome, genetics, and lifestyle. A one-size-fits-all supplement won't cut it. That's why researchers are leaning toward postbiotic personalization, sequencing your microbiome, measuring your blood metabolome, and then designing supplements tailored to your unique biochemical fingerprint. It's like a Spotify playlist for your cells, but instead of music, you're streaming indole derivatives. There's also the thrill and slight terror of synthetic biology. Why wait for the right gut microbes to show up when we can engineer bacteria to live in the gut, produce anti-aging metabolites on demand, and secrete them directly into the bloodstream? E. coli that makes IPA. Bacteroids engineered to squirt out butyrate or GABA. Think of it as gut-based gene therapy, without the injection, just a strategically placed yogurt. And don't forget the regulatory curveball. Aging isn't a disease yet. That means these microbiome-inspired supplements won't be classified as drugs unless they aim to treat specific conditions. But their potential as health span optimizers, enhancing energy, reducing cellular stress, preserving cognition, will likely put them in the same spotlight as adaptogens, nootropics, and mitochondrial enhancers. The difference? This generation of supplements will have mechanistic clarity, not just folklore. In the end, blood microbiome research has pulled back the curtain on a secret conversation between our gut bugs and our bloodstream, a dialogue that influences how we age, think, and heal. By decoding this biochemical chatter, science is poised to develop a new class of supplements, not based on what we think helps, but on what our own molecules already know does. These won't be pills of hope. They'll be pills of informed mimicry, translating microbial wisdom into molecular medicine. The future of anti-aging might be built not in labs alone, but also in the long shadows of our own bloodstream, where bacteria whisper and science finally listens.